to scan. Just scan is very easy. Just click scan, you will get the picture. And also here, this is you can put your file, set up your. This is just a set file, but this is later will tell you this one. Like this one put your file name like this. You can set your folder here, and save all of your data. Mm-hmm. That's very easy. Just for use, just to use AFM is very easy, but set all of those kind of things is very difficult. Mm-hmm. Yeah, this is why if I put all everything good, you just come here to use, it will be easy. And also, if you want to, for example, you found your picture not so clear, you need to change this circle, change this data. But usually we change this one, maybe, or you can use the volt, increase volt or decrease volt, and see the picture. If you got very clear, it will be fine. And also the scan rate, you need to change this scan speed, the frequencies here, and then usually the slower is better. You know what I mean? And also the zero it doesn't matter. You don't need to care about it. And also this when you do scan the wave, another one is called the not this one. And let me see the rotation. You see the decrease, right? You don't need, even just keep the zero is okay. Zero doesn't matter. And let me see this one things. The first thing is loading a sample. Once I put everything there and put the beam, we can find the laser on the correct location. The intensity must be strong. I will keep it there. Once you come here, you just load a sample, and then turn it on. Very easy. And then you need to set your this is the channel, right? And also this set up this kind of things. And say which mode you use. Once you get it, and then get this one and see this one, right? And then this one done. When this one done, you need edit what data you want from here to this list of. You can choose several of them and you want. In that case, after this one done, what you need to do, everything is good, you need to click approaches. But right now, we cannot do it because we already ended it, right? End the program. This is a click approach. Because this pin is like that. To go this, after you got the very clear pictures, I mean the picture, the camera focus very well, and then, but maybe that one is still not approaches the surface. Once you click this one, this get a little bit more closer to your sample. Once it's done, just click scan. It's done. Once everything is done, click end. Take sample. Yeah, understand? Only part step is you define the laser on the correct location of the off tip. That's very important. Otherwise, you cannot get this one. This one I said at that time we already get it. The green spot there. This means we already there, but we didn't do scanning. This is why. He said maybe it's not his sample. This is why we want to check is this one or not. Is this correct or not? And then when we take it out, we'll make it out of memory. Sometimes it's like that. Sometimes happens.
So what happens if we are out of range and we do scanning?
We have to put the laser on the location.
We don't get any signal because if the detector is not on, it's not blind, it doesn't see.
Yeah. No, let me tell you. Okay, this is your your probe, okay? Laser must be in this way, on this location, on this location. If it is go this way, or here, you have to select it, right? You have to find it. To find it, you need to use all of those four. Those four is very it's hard to adjust. Those four. This is PSP, I told you. This is position sensor, photo detector. And these two find the laser location. Kind of this one, all of the four should almost do the same things, but first you need this one to find the laser first. But right now we cannot find the very strong laser on the teeth.
Yes.
This is why. I don't know why. Maybe we adjust too much from here. If I adjust too much, it's hard to put it back. Okay? I will try myself later, okay? Oh, this one is here, right? This spot. You see?
Something is there.
It's there.
But the intensity doesn't change at all.
Yeah, because we didn't find the laser here. We should have put the laser in the location.
What are you adjusting when you're turning those? What are those adjust?
This one for the focus, for the camera. This one for the laser.
Okay.
That one also for the laser. This is adjust the red spot to the origin, and they become green. Yeah. I told you guys, very difficult to focus on the beam, get about 3 volts intensity in terms of intensity. This one down, this yeah. You approach it to yourself. Do it, yes. Oh, right now maybe we cannot do anything because we have to focus again. Everything. This is no even the beam. No, this is no light, right? The beam. We have to do a lot of things in this case. You do it like this. Was it too? I did too fast, right? Slowly.
Yeah, it's not a sample.
Ensemble?
Contacting in the sample.
Yeah, this is too far. Or too close, right? Yeah, this is better. You see? It's good, right? Yeah. The light is laser is still here, right? Let me change the laser.
So maybe next time we turn off the beam and because of that it will go green.
Which one?
Last time that we removed the sample,
Yes.
we didn't see green. Maybe the beam was off.
Being off? Let me check, okay? If you do it like that, this one will off. And then that one, you see, this is the beam. Okay, let me adjust this beam. Okay?
It's going.
Yeah, that's good. What else?
You see, if we turn off the beam, there's
What? What else do? Oh, maybe we push click beam off.
Yeah, it's just saying.
It could be, right? Let's try again, okay? Let me try again. So it's important we need to understand because I'm not familiar with this one. Maybe it could be this reason. Peter?
What?
Peter. Okay. Let me try again. Okay. Right now it's being off, right? You on. Focus, stage it down.
Okay, that's enough.
Is this enough?
Yes.
Let me focus. Eli, it's different.
Yeah, it's
It's different. That sample is your sample.
yeah.
That is your sample color. It's different. Okay? Let me adjust this one. I want to put this one here, almost in the center. Oh, goes away, right? Oh. Oh, I think I did do it. Okay, I'm sorry. Let me put this one. I have to again. Looks like your sun is green. It's green. High enough, and then if you, for example, if you want to take a sample out, this is still high enough. You need either use this one or use your finger. Use this one sometimes is very difficult. This is why, because you have gloves, doesn't matter. You can push it a little bit out, like that. Right? Push out and do it like that. Or if you want to just use the tweezer, maybe you need to do like that. So mount it like that, okay? Or take it out, grab it, but you need to slide, didn't leave it. Otherwise you break tip. In this case, you can make sure get in this one. This is very important, that one, because this one you have to do yourself. Because if you want to change your sample, you find there are a lot of broken tips. So student maybe use this one. Do it like that. You will break it. And then we need to adjust we call it PSDS position sensor, PD, the photo detector. This red circle, do you see? We have moved this one to the center. Once you move this one to the center, it will become green. In that case, it's ready to use.
What do you change now?
Use this one. Tell you that one, usually this data is about 3 volts, around 3 volts. Once you get there, do you see it can move, right? And then up. also this is a trick. This is hard to adjust. That one. It's good, right? Right?
Yeah.
It's how much is 2.99, right? Volt. Yeah, that's good. I think that's good. Once this one done, what you need to do? Let me see here. Okay, just follow this one. And but usually for you guys, I don't suggest you guys you load the probe on here. It's very easy to break, and also it's hard to find this spot and also the laser beam. It's hard to find. Even you hard to find the probe. All of this work should be my work, my responsibility. I should, for example, if you want to use something, you tell me. I will make everything ready for you guys to use. Otherwise, you may break it, right? The break is like this is about $30 each. Yeah. I found that guy. I asked those guys if there's something wrong, they should write down here in that kind of logbook, but they didn't write a lot. Okay, that's very important. And also let me put a little bit down to see what. It's okay, it's good. And then once everything is done, you come here to set all of those parameters you asked me. So for example, what kind of mode you want to use, and also this number, NCHR, that number you will put in. If you use another one, maybe it's just a different mode. There won't be very big difference. Or AC 160 TS, like that. If you use this one, just select this mode here. Okay, come. Let me check it. That one is all everything is good. This is here, cantilever, and a line beam. You see it, Miller. You see this laser. Move to here.
Okay.
Yeah, just as I did. Okay, and also the 2 to 3 volt.
Okay, I can see laser here or here.
Yeah, that's another, but you found this one here, right? That's good. This is,
laser?
yeah, that is laser. That is laser, yes. And then you need this I already did this one, non-contact mode. This one selected, and then channel should be. I don't know why this one. Not give it a smooth. Oh, they need to do this one first. Maybe we don't need to do that now. We don't need to do this one. But I don't know why that one didn't come out. Once I choose this one, you should ask me to put this number here. Oh, okay, maybe this one? No? Maybe that one right now we don't need it. Oh, okay, that one is for this part. Position. Oh. Set up. Oh, okay, cantilever is here. This one, oh, this one, yeah. Or you have a lot of choose selection here. From here. From here, right now we use this one, right? We put this one in. Then you need to put the NCHR. This one. Okay? And then this one off. And then now, what you need to do, you need to do this one, edit. For edit, depends on what the parameters, the data you want. For example, if you want to use, we use a lot, if you want to get the image, okay? We need to select height. Or if you want to that one, NCM, non-contact mode phase or amplitude. You can choose this one as well. Maybe this is height. For the images, I suggest you to choose a height.
There was a Z height.
Where?
You passed it.
Sorry?
Z here.
Oh, yeah, Z height, yes, you're right. Z height, and also, let me see, just found this one is a face, right? Where is the face? Oh, it's this one. Okay. And also, I think maybe I did choose this one, adding. It will come here, you see? And also, if you want frequency, also you can use frequency. Depends on what you want. See height, edit. What do you want? Frequency. Or why? Maybe for example, if you want to get the height, right? Sometimes we need offset. Yeah. Or you can choose this one as well, or you can choose the other. Let me see. What do you want? Sometimes if you want to get mechanical properties, you can choose the modulars, deformations, that kind of data. There's a lot. You can choose a lot. This is depending on what you want.
What's the phase, NCM phase?
What?
What's the phase?
Where phase?
The NCM phase.
Future
What the,
versus-
which one the first one?
NC is a non-contact mode phase, right? Phase means kind of phase, because it's always doing like that, right? That is called phase. Like vibration, right?
Yeah.
This frequency, right? Kind of the phase.
So what do we get from that?
You will get it from here. We show like this. Usually do it like that, right? This is called phase. Yeah. And what do we need? Let me modulars. Modulars maybe we don't need it from here. And phase. We can select several. Doesn't matter.
For example, you just want to measure the height or some other information.
If you want to get the image, right, you have this height.
Yeah, I'm
See
just
how-
talking about that.
Yeah.
For this one.
I think maybe we just select not that much. Maybe let me choose this one, just 4. Okay, this doesn't matter. This is data. And then you need to click apply. We can choose 1, 2, 3, 4, 5, 6 total, right? Yeah, we can choose that. And the next, what you need to do, and also you need to make sure that one is still good. And also, this one, you need to select area. and this server just usually for X, Y, this is showing the pixels. And then most time we just do 256. But anyway, you can change. If it's more of pixels, in this means it's, you have more high, maybe kind of high density, right? In that case, maybe there's engineers that don't change this one a lot. Usually just use 256. Yeah. And also, this is size. Size means how you can click here. How big area you will scan.
Okay.
You can scan like the 1 by 1, 2 by 2, 5 by 5, and then the maximum is 50 by 50. Micrometer. This is why I told you this is very small.
Yeah.
This, if you just want to get the height, the thickness of the thin layers, maybe this one not so accurate. Because this area is too small. Use profilometer maybe. Maybe it's better, you know? Yeah. I think that's it. Okay, now what you need to do, but usually this one you get this nice scan, you will scan like that, okay? And then to get the image. Right now you need to find the area you want to scan on your samples.
Yeah.
Well, but for this one, how can you do? You can do like that. It's cancel, okay? If nice guy, don't need. Use this one, you need to this stage you will see if it goes down, it's fine.
Let's see.
You done? Do you see the
Let's change.
it change?
Yeah, it is changing, but
It's hard to tell, right? Okay, use this one to change location. Use this one. Let me see. Okay, let me just focus your sample, okay? Because right now the camera just focus on the probe. Now let me focus on your sample. We need to find your sample. Use this one, you see? Can you tell me from this side?
well, it's nothing compact.
Nothing, huh?
No, it's nothing compact.
No, we need to make it down. Yeah, this is too high.
Okay,
You see?
yeah.
I still can see your sample.
Yeah,
Hey, tell me.
it's constant.
No, tell me your sample's color is.
No, you're up. Go.
Is this your sample? This is not your sample. Come here. Is this your sample?
No, it's not. The sample is, I think, the green one.
Green one.
Yeah, I think.
It's here, right?
No. The other way.
Other way, right?
Yeah, the other way. Go further.
Go further?
Yeah. You're at the edge of the sample and the out. It's out.
Oh, it's out. Oh, it's out. I need to move to this way. Oh, it's out?
No, it's going, yeah, it's getting better.
It's better?
Yeah.
It's good?
No.
How about that?
No, it's getting right at the edge.
Okay. I did see changes this X or Y stage. Again?
No.
No?
No, it's not changing that.
Not change.
No.
That's weird. It's almost on the edge, right?
Yes.
Still not correct?
Yeah, it's not there.
Cannot move. How about that?
No, can you go to there? It should be moved to the valve.
You're not good?
Yeah, getting better. Do it better. Yes. More,
Yeah?
more,
Yes?
more, more.
More? I can't move it.
Yeah, it is good. Yeah, it is at the center.
This is summer, right?
Yeah, this is sample, that's the center.
Got it, right?
Yeah.
It's on summer, right?
Yeah, it's on sample.
Oh, that's good. Yeah, on summer, yes. Okay, now let me focus on your sample. No.
Why it's green?
Hmm?
Why it is green?
The sample is not green, right?
Sample, no, sample is silver.
Sample, what color?
This is silver.
Silver.
Yeah, right there, there we have.
Let me check this one. Is good. Laser. Usually we have to put a laser in this location, about this location. In the almost in the center.
What do you change there?
Oh yeah. Okay. Those two we call it you use this on the focus.
Okay.
This one we can adjust with the laser. Do you see?
The beam.
Yes, that's beam, yeah. This is beam, yes. And also this one, the left, right.
So where you should do it?
What?
Where should? How do you know that it is good now?
I told you, you need to put this one here. This is strong light should be around here. Goes away, right? Do you see that light? I move this one will come here, right? And then down. This one is difficult to adjust. Okay, let me see with this one. I made this one. And then be on cantilever, focus on cantilever. Correct you want from here to add. And you can get a lot of, from here, you can get a lot of the selections. Do that. And then apply it. Okay, let me, hold this one. Good. Shoot. Oh, that one, come on. That one, good. You see?
Are we looking at this?
Yeah. This is very important. Because you cannot see it, right? But it's hard to see it by your naked eye. I write down this one, I just took out this one, right? And you write this is the bad one. It's broken. All of them are broken. There's no, you see? No problem. Let me find you one. Miller, can you find, you use your naked eye to see that one? No, you need to take it out.
Right.
Because we have a lot, I don't know which one
Okay.
is good or not. No, let me tell you how to do that. Take it, grab it out, and see the,
Yeah, there's a.
yeah, that's the tip, very tiny, okay?
Yeah,
Don't drop it.
there's a line.
That one is not good. Can you see?
Yeah.
Is the line? No, unified line come out.
Sorry.
Line must be out.
Okay, I'm sorry. It come out of.
You see, this must be out of this, come out like that to here.
Okay.
But this one, nothing, you see?
No.
This one, let me see. This one's broken as well. You can you see that one?
Yeah, there is some line on it.
But we can see if it's come
Is
out.
out or not?
We need to see the dark spot.
Looks like there's nothing. It's broken. This side. You must be very careful. Oh, okay. Put it on and then it become red. Yeah. Okay. And let me check if this one is broken. Sorry. What is broken one? You see the no probe, right? Yeah, if it says probe, I told you, it could be like that. You know what I mean? Kind of a stick come out.
Okay.
Yeah. Oh, you cannot open it.
Oh.
Oh.
You missed.
You've got it.
Oh. Okay. Well, this one is broken. 你这改进，这 student should write it down here. The broken knot. to break a lot of the tip, probe, tip. Yeah, also we can cut the probe or tip, okay? But they didn't tell me. Hold the laser and take it out. It's better hold it like that. It's very dangerous. Pretty easy to break the tip. If this was broken, you can't use it anymore. You have to take it off. Take it off. With this one, it's better to use this one to hold it and put it like that, okay?
Again, back in.
Yeah, but I'm afraid that I don't know which one is good. Which one? Maybe this side is better. Oh, this one looks like broken. I found this not the users the broken lot.
Will we again put the broken in the same box?
Just save it, right? Just save it.
You don't throw them
Maybe
away?
I think maybe in the future, if we want order new, we can send this one back to the vendor, kind of do trading, right? Yeah. They maybe give us some because they just put this part on it, right? I mean, this is a probe, right?
Yeah.
And then they can use that part, right? Those parts. Oh my God! I found this.
Broken?
Yeah, this didn't.
I don't know. It's broken.
Could be. Some user you break it, but you see, but they didn't tell me. This is not good. You see, it's not good. Next time I need to tell them. This is a pin. The pin touch it on the surface of your sample or doesn't touch on your sample. But still it can move as vibrate like that. Right? Yeah, this is kind of like that. So it's moving. This is how it works. In that case, you can maybe detect your sample surface, like the roughness, this kind of things, right? Yeah. Or right now, with the AFM technology development, we have a lot of the mode we can use. But now we have 7 for our case. But this is total maybe more than it's about 15, but we have 7 of them.
Which one do you have? Which one of these do you have?
We have the non-contact. It's a contact mode.
Okay.
Non-contact mode, you see, and we can do that one, conductive flow, pinpoint conductive flow.
Okay.
Using the ID in the spectroscopy, and also we have this one. We have this one. Oh, we have this one. Scanning funny, almost the same. So total about 7. Total we have 7. And then like this one, we have contact mode is here, non-contact mode. But this one, most time we just use non-contact mode, because the contact mode is easy break the probe. With the non-contact mode is more safer. It's much safer. Okay. And but sometimes it depends on what you need. For example, there's a guy from the biology department. That guy, biology engineer, right? That guy, she did a lot of got a lot of the image of the protein, the kind of lead fiber protein of protein. Yeah, she told me she has to use the contact mode. Yeah. And also the conductive mode, as I said, the conductive. Using the conductive mode, you can measure the IV curve.
What?
IV curve. Sometimes I remember the last told me, right?
Yeah,
we never use it because this one is pretty new machine. We just got it last October. And around maybe the end of the October, that engineer, this vendor engineer come here and provided the installed machine and also provided training for us. Pretty new, even to me, also pretty new. Okay, still I'm learning about this kind of technology. Yeah. And also with STM. STM is an example, right? STM, we are using STM. Oh yeah, STM, yes. And also SCM. SCM is this one. SCM. The terminal. Yeah,
Under tunneling, there's SCM.
but I remember this one. Oh yeah, we did this one, SCM. But this one complicated to use the sample is a liquid. Yeah. And STHM, the total is the same. Okay, STHM with STHM pinpoint oh yeah. STHM actually is a thermal microscope. Okay, the thermal microscope. Okay, the AFM the kind of this equipment is not so complicated. We have, you guys know the profilometer, right? Profilometer.
Yeah, profilometer.
Yeah, you know that? Yeah.
Yeah.
The principle of the working AFM working principle almost the same as that one. Next time. That one is move, right?
Yeah.
So step and go up and down like that. This one is just complicated.
Okay.
The machine is like that, okay? And this one is very, very precise and also very, very fragile. Here. Okay, this one we call the head, okay? Let me take it out and you guys can take a look. And that's so if you come here to see this one, you see this kind of lock. The right one and left one. And after you press it, you fix this one, the head. We call this part of head. Head is most important. Yeah. And then you can release it and to slide, hold it and slide it, okay? You see? Be careful, this is very, 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 very fragile. Okay. This part is kind of, we call it a probe. It's made of the piezoelectric materials, very, very tiny, very tiny. Even you can't see it. Can you see this? That kind of needle. Can you see it? Can, right? Don't touch it. Don't touch it. Don't.
No, I'm not touching.
Yeah.
I mean that you showed this way.
Yeah, this way.
Okay.
Do you see this is kind of the line on the surface. Can you see? You see? Can you see it?
I'm not sure.
Yeah, it's hard to see. How about you?
What am I looking for?
Yeah. This is line in the center.
Okay.
Do you see?
No.
You can see?
Uh,
No. Oh, pretty sure.
If you mean this one, yeah,
No,
I can
no.
see.
The
You
line?
can see, right?
what is it? A line?
Yeah, you kind of wire, very fine wire.
Uh,
No, I can't see.
Can you?
No.
No. Okay. Let me show. Yeah. Maybe this is not good. Yeah.
Okay.
You can see it? You kind of the metal wire. You can see. Okay. In the center. Straight line.
on the very top?
Yes, very top, like that.
Uh-huh.
On the surface, even you can see that one, right? This line
Uh-huh.
and this line goes up.
Yeah.
Goes, oh,
that
yeah.
line.
Yes, it's very small.
Yeah.
It's hard to see, right? It's hard to see. And that one we could probe hand. This one is called probe. This probe hand. Okay. And this even most of them also we call this line. I just call this one. This is called probe as well. Okay. Yeah. And also here, this is camera. Okay. And also this one, you see this one. Complicated to see. This is laser. Do you see laser off and on?
Yeah.
Right. This one, for
green
the turn on your laser and or turn off your laser. Which
Why do we need
laser, because you will see this laser will let me see laser will be focused on this probe, okay, and then you will use this laser. Oh, is that question I cannot answer you. I'm sorry. Okay, I need to think about this. Well, we need laser. You're right. Yes, but this one. Let me think. The probe. We have to have camera. We have to have laser. Okay, and also.
this beam, you mean laser?
Yeah, this is laser. Yes, this is laser. And you see, oh, maybe the laser.
Oh, it's for the modulation. Yeah.
Kind of that.
Keep go out, up and down.
Up and down.
It will modulate
Oh,
that
whoa,
laser,
whoa.
and we can see that.
Okay,
No,
well.
what you do?
Yeah, the modulation of that beam. Yeah, we can see with the detector. So we'll see the change of this tip with the laser that will go to the.
I said detector to the detector, yeah. But still, we need to think about why we need a laser to do that, right? Yeah, because this one, that probe move is not controlled by the motor. You know what I mean? Motor controls the probe movement. But okay, because this one move laser will focus on the probe, and then with this laser we can find
Height.
the height and the change in x, y, and z. This is why we need a laser. So could be reason. Okay, yeah. And also, okay, that's it. For this one and also this one, this is a magnetic sample holder here. Yeah, this one is if you want to see your sample, you have to put your sample on this side.
Yeah, Dr. Shi
Yeah.
tell us to.
Yeah, you can yeah, but you can use double side tape or glue, but it's better use the double tape or double-sided tape, right?
Do you
Yeah.
have double-sided tape here?
But you can put this is double-sided. No, this is double-sided.
Okay, this has.
Yeah, you can feel it. See?
Yeah. Okay. Yeah. I see.
Yeah. Okay. And then this one, this is a magnetic. This is magnet, and this is metal, right?
To holding this one.
Yeah, hold this on. And also the X and Y, this direction is Z direction, right? Yeah. Yeah. Oh, that one is better. I should mention that. This one, when you took it out, you cannot hold by hand. This is very dangerous. That probe is very easy to break, okay? But usually we put it like that. Oh. It's like that, okay? Just do like that. And this is that guy. You can usually you use the two fingers hold it, and this, you see this one. We call this called the rubbing. Okay, rubbing 1 and 2.
What's that?
It's kind of the make you easy to find the location and fix it, okay? But this still this magnet. You see? The magnet, right? And you do it like that. Oh my God. This, I'm afraid that one was already gone. It's easy to break, okay? Okay, like that. I don't know if this was still there or not. Maybe, I don't know. I did use that one cheap. Okay. And we, after this one, you got it. You did put hold it like that, and slide it from the right side. And put a switch back. And then, oh, where is your sample?
I gave it to you.
It's here.
Oh, yeah.
Why the light changed to red?
Oh, because this one, you turn it off, right? You turn it on.
Now when you remove this part, it changed to blinking green.
Yeah, but
Oh,
it's the lock, I think.
The lock. This one, and you see this one? Wait, let me put this one. Oh, you just light is on red. Maybe this is means maybe the laser is on. Off. Yeah, I think turn it on. Didn't change, right? But you need from control from this side, from the computer. And also here, we have this was the software. We call smart scan. Don't use this one. Okay. And then this is the head, okay. I'm afraid of that one. Alright. Right now, you see this one? This is laser. Okay? That is laser. But usually, this beam is actually is laser, okay? You turn it on from here, but first you need to turn on this one. This one. And then come here, also you can click, turn it off, turn it on as well. And also with this one, the first thing what you need to do, if you want to turn off laser first, also is good. For example, you can turn off this one, you need to find the probe. To find the probe, you need to adjust. I'm afraid that this probe is already gone, we cannot get it. Oh yes, this is low. Oh, we need to change the probe. The probe is broken. But usually, from real probe, we cannot judge if it is okay. But from here, we can see. From here, you can only see this part, right? See, without the probe come out. If the probe is okay, there will be that kind of stick come out. You know what I mean?
So we should change probe?
Yeah, we have to change. I think that probably, I don't know if I just break it or just the last user break it. It's very easy to break. Now it's on. Come to see. It
Yeah.
must be off.
The switch.
You don't forget that.
Yes.
Okay. After done, you need switch it off. He's coming?
Yeah, he's waiting for you.
Okay. And then here. Can you do it yourself? Oh, maybe you can do. You have glove. Yeah. Take sample off.
Okay.
Yeah.
In that case, you must be very, very careful. Okay. Don't leave it out.
Okay.
It's just slide.
Slide it. Okay. Is this just this white part?
No.
Oh, this part.
The second one.
Oh, okay.
Oh, okay. Let me show you. Okay, do that. Sample is here. This magnet
Okay.
is hard to slide.
Mm-hmm.
Okay, let me do it myself. And then, give me the tweezer.
Here.
Tweezer. And then, can you do that? Get the tweet.
Just push it.
No, somebody, no, pick it up.
Pick it up.
Pick it up, right?
Mm-hmm.
Don't leave it out
Yeah.
to hit the probe.
Yeah.
That's very, very important, extremely important. Okay? Otherwise, it damages the probe. This one, that one is magnet. This is magnet part.
Yeah.
Okay? This is yeah.
Okay.
Okay, you have to know that, okay?
Okay.
Yeah, that's it. And also the software. You need close software.
Okay.
Can you use the data?
Just X.
Use those data to change it. You change this data, you can get it.
So what happens if we decrease the scan rate? It might get better.
Scan slowly, yes. You can change it a little bit, yeah. Don't change a lot, I told you, right? Usually change it a little bit, do it like that.
A little bit, what do you mean by?
You go 9, like 9.
Let's do 8.
No.
8 is too.
Point.
8 is not good, right? I remember. Oh, don't forget the other one. This is important. Don't type the wrong data here.
Yeah, I know.
You may damage something.
Yeah.
Yeah. I remember this one told me. If you change the very fast, you damage something. Yeah.
So
don't forget.
now it's fine?
If this one put, for example, you put 10, 20, oh my God, this is terrible.
Yeah.
You know what I mean?
Yeah.
Yeah.
Nice scan, yeah, that's fine. I just
No,
changed this one.
did you ever see?
I just changed this one.
Just change
From
this one.
1 to 0.8 hertz.
Okay. Yeah. You can.
Now it's
But most people would like from 0 start, but doesn't matter. That one. And here, if you want to change this one, But right now you cannot change, right?
Okay,
Yeah.
it doesn't matter.
Yeah, that doesn't matter.
But you still have
I'm pretty sure you guys need time to practice.
Yeah,
Yeah,
we can figure it out.
No, but after today, if you guys get in, you have to pay, okay? You know what I mean? Yeah, this is not free. You cannot all everything comes down to use it.
For me, I definitely will pay. For the other one,
No, I'm manager here. I have to let you guys know it, right? Because you know, all of this stuff we need to buy, right?
Yeah.
And also expensive. This morning, Darwin told me, don't let the user change the use the probe freely. This is very bad. There's a lot of money will be waste. I found I don't know why a lot of the broken pieces there. This is not good. And also, I remember you guys, I have to remind you guys, every time when you come here to use it, you need to write down the logbook. I need to do that as well. Yesterday is 30, right? And the student. And the length. Oh, 30, not here. And for IC course. Yesterday we found problem is no laser, right? Spot 5 found. Oh, change the probe. IC course. Actually, Mila, let me tell you. For today's class, you shouldn't become beginner.
What?
Just joking, okay? I mean, you shouldn't be here, right? For the training, usually we need to charge the user. Just kidding, okay? That's okay. I see course, and also today everything is fine, right? That's fine, okay. It's not done yet? Should be done, right?
No, not yet.
Oh, it takes time. I don't have time because I have an appointment at 2. Another appointment. What time now?
1:30.
Oh, okay.
Half an hour.
Half an hour, okay.
It's getting better than this, but still.
But still have, right?
Yeah.
But you need takes time to adjust. You need takes time. Not today, okay?
Okay.
But the data is very good, you see? That is very good. You see, almost overlap together, you see? Very good. It's good. No, you need to wait, right? Not now, right?
No, I know.
Yeah. Because she need to do it and he need to do it.
Yeah.
It's better you guys should do from the beginning. But right now we don't have time.
Yeah.
You know what I mean? Yeah, it's better from the beginning.
I
The
know.
focus, this stage adjustment, XY stage adjustment, and also parameter setting. But right now we don't have time. takes time. I don't have time to wait here, okay? And also the other user will come at 2 p.m. This is why we can do it.
So we can wait in other time? Or
No, for the class, I think, I don't. In that case, I will give you guys 3 times class, right?
So,
But anyway, are you familiar with the whole process? No? No?
yeah, we don't.
You need another time?
No, that's fine.
You can, when you log it, just let me know when you guys can come, okay? Just fine.
yeah, you can talk with Dr. Shi and tell her what you can do, maybe.
Yeah, for example, you guys have to tell Dr. Xu. You guys should say, I'm very, I would like to do more AFM training like that. You can let him know, and then he ask me maybe. Because we didn't charge anything for you guys, it's free, completely free, you know. And also, the time for me is not that much. I'm not available every time, right? This is why we should communication between me, you, and your professor.
Yeah.
You know what I mean? That would be better. I
Yeah, you
cannot
want
do
to
it. For example, today I didn't let Dr. Xu know it, right? It's better for me letting him know it. Because I provide service to you, right? Your professor doesn't know, doesn't like this. Okay? Okay, so
So do you want to do it? Or?
What should I do?
If you want to,
You can change
you can do that.
your-
Okay. If you want to do that, you can end it,
Do it again?
do it again. Can you try?
Yeah, do it.
No,
yes.
no, you should
I
do it.
know. I mean, like maybe Milad needs to do some more for his sample.
No, it's
Okay.
just you will do it on the same sample, I think.
And also, I think you guys will work together. Okay? Come here. You work together. You can do it now, right?
What should we do first?
Mm.
Okay, let me tell you. For this one, let me tell you again, okay? This one, you will put hand here, the finger here. It will move down slowly. Okay, this is, this is a line here. It's a kind of a boundary between
Yeah.
fast and up, between up and down. Up, above this one will be up. Above, below this one, it will be down. You know, if you put it very close to here, down very slowly. If you put here, very quick.
So how we know that we are so close to our samples?
Oh, in that case, you need to find if let me tell you, okay. If you find this here, put here, right? Okay, in that case, you need to focus. You can find a sample. If you find a sample is very clear, it is very close.
Okay.
But still not close as after you clinic approach. Okay, do it. Well, now still you just focus on the team. You should focus on your sample. You know what I mean? In that case, what you need to do, you need to keep going down. You know what I mean? Yeah, if this wise. Because you didn't find the sample, right?
Yeah.
That is the limit, you see.
Interlock.
Yeah, limit, too much. And then do focus. Focus on your sample. No, this blur become.
I guess we could look at like that dot to see if it's focusing in on that.
Yeah. He's right, yes. If you found some dot become clear, this means your focus will be better. And also, this environment, you need to see sample, not this one, not a probe.
So
You can click this.
it's
You can click. Probes are too much. Speed of the tip will be 2 times scan size over scan rate. And the too high speed will result tip and some damage. And all this I remember somewhere said.
So maybe it's too slow because it seems like the higher the scan rate, the slower the tip speed.
Yeah, yes.
It just seems weird. Is it scan size divided by scan rate?
Oh, this.
Or maybe the opposite?
No, but this should be opposite. I don't
Yeah,
know.
it should be opposite,
Should be
right?
opposite. Okay, maybe.
You'd think bigger is
Maybe this is not over, right? Maybe there's something wrong with this one. I remember that the engineer told me that one if you're too fast, it's not good.
Yeah.
Scan rate is too fast, not good.
Yeah.
Maybe there's something wrong with this one. I remember somewhere told that if you scan very fast, you will get the line.
Yeah.
Straight up.
That makes sense.
Yeah, that makes sense.
The image looks really cool. Even without
Even-
lines, you can see how.
So I have to remove this one to save line.
Yeah.
Maybe we can use this one again.
Okay. All right. I actually have to go, but
You can use it, right?
yeah. Milada, you know what I want from the sample, right? Data-wise, like this scan obviously is really good. I think.
Yeah.
Just make it without. the
And also
lines.
you can see, this is very good picture from here.
Yeah,
right?
exactly.
So overlap very well.
So all
The
the
forward and backward, this line, one is a backward, one is forward.
so the real data that I want, good pictures, but this looks good just without the lines. It'll be really strong, and then the width of these. And the spacing of them, and then the height differences.
Oh, do you want to load that one as a software, to analysis software?
Yeah,
Okay.
I've played with it before.
You did it?
Yeah, but
Okay.
I'll probably play with it some more. I just have to leave now.
Okay, do you need the difference between this valley?
Yeah, and that peak height. Yeah, and then the spacing between the center of the valleys, and then also should be roughly the same as the spacing of the center of the peaks there, and then the width of the peaks and the width of the valleys, stuff like that.
What is this sample?
Huh?
What is it?
It's PBSE on germanium, but the substrate has this like tilt or miscut, so the growth forms these like it's a special type of growth mode called step meandering. It's kind of hard to explain, but yeah, it causes this weird surface feature that you don't see very often, and by analyzing that surface, like the spacing of those lines, the thickness of those lines or width, and then also the height difference between like the tops of them and the in-between parts,
Yeah.
it'll give you
No,
information about
because
the
if
growth.
you in
Okay.
future you want to use it,
Thanks.
this is why I ask you, I don't want the user to damage anything.
Yeah.
Yeah,
Yeah.
yeah. Because if you damage something, we need to spend money and also we spend time. And also maybe other user cannot do it.
So is it done?
No, not done yet. Oh, it's already done, right? Oh, it's already done, okay. Already done, come here to see that other data. When you come to this one, to this side, and then you can open your file. And this is I did before. I don't.
It was the SPM data.
Yeah, but let me see. It's better to see the details, right? What time now we got the data? What time now? One.
It's one.
Maybe it's here. You have to. This one. This is from here to here. This is yours. Others I did this morning, okay? I did myself. And then, if, for example, you want to see this one, just open this one. And then, if you want to see, then, oh, this PBS is this, oh, this is the idea.
Yeah,
Okay.
this is the previous.
This is your, we just got, right?
Yeah.
Yeah, it's this one. This is your data. I think the images, it looks like fine, it's good.
Yeah.
And then if you want to see the 3D, it will be like that.
Okay.
It's a very beautiful data.
Yeah.
Very beautiful.
Yeah, this one.
Yeah, very beautiful. I think it's good. Oh, very beautiful. Oh my God.
That's nice.
Yeah. I don't know why your sum is like that. They circle a lot.
These?
Yeah.
These are the,
Why?
because the substrate has some miscut in it. So when you grow the film, it will grow this way, and then we have a step, and then we grow another step. It's something like this. It
You mean
comes-
that maybe there's a miscut
Yeah.
away from the orientation?
Yeah, you miscut out the wafer is not completely flat.
No,
It has a
let me
60
tell you. Okay, this is your sample.
Yeah.
Orientation, for example, is 100, okay?
Yes.
100 means this direction, right?
Yeah.
You mean maybe you cut sample a tilt, a little bit tilt?
Yes, it is not a complete 100 with it.
Yeah,
has
this is
a-
what I'm saying. This
Yeah.
is deviation.
Yeah, it
This
is
is a
something like
deviation
this.
from
It's-
your 100.
Yeah, it's yeah.
It's correct, right?
Yeah.
In that case, form to this.
Yeah, when you grow the film, it.
Oh, okay. Well, this is reasonable. It makes sense. Huh? Okay. No, it makes sense. And also this one, you see, we have a lot of selection from here. The information, this one, you get a lot of data from here.
So
okay?
what are these? The amplitude.
This is almost the same as I did. 3, I did this morning, let me see. Yeah, these are the same things, you see? Right? I did sweep, I told you, right?
Okay.
Did you remember? I
Yeah.
use this one to get the data?
Yes.
Yeah. This is why that sample is good for, use this data, you can get a good picture.
Okay.
And also this server game, I used 1, you see? And also this X, Nancy said this one is important, right? Oh, this is not offset, this is not offset, this is not. Show details, let me see, there are a lot. You can find what you want, okay? From here, to a lot of things.
I think here we can.
Yes, it's also you have already automatically saved.
Yeah.
You can change it. You can get this one.
Okay.
I don't want to do for you. You can do yourself, right?
Yeah.
Yeah. And also 9, this one doesn't matter. This 9 you can select this one. For example, do a line.
Yeah, this is better. I think
You-
I can use this one.
You want to use this one?
Yeah, I think it's better.
You like this one, right? Okay. Okay, use this one, okay?
Okay.
Do you want to use this one?
Yeah, maybe the
No,
tilted
this one.
No, the tilted one.
This one?
This one because we need something like this.
Oh, tilt.
these are oriented.
You want to tilt?
Yeah, tilted one because we want the cross section of this.
Oh, let me check. No, it's not this one.
What's that?
Not this one. So this just change data like sorry. This. Why is this one not working? This is. This
Maybe
one.
you can have an angle here from here, a rotation from here.
No, could not.
No, just click, for example,
Oh,
20 maybe.
you mean that one? Okay. For example, 10. Okay.
No, it's 0.0001. Just click 10 here.
10 here.
Yeah.
Oh, I like that.
Yeah,
You,
but-
you like this one?
yeah, no. What changed it? Where's the 10 degree? Here? Is it? Yeah, I think, yeah, it is.
This is 10 degree. Yes.
Yeah, click minus 30.
Minus what?
Minus 30.
30.
Yeah.
You like that?
But it doesn't change. It's not, no, it's another thing, I think.
Oh, I think
Yeah.
I don't think this one is
Yeah,
correct.
that's another.
Maybe. No, I think that one should work, but I don't know why that one not working.
What's this one? The other one?
This one is like that. Hmm?
No.
This should work.
I think it's selected this one. Can you delete? Yeah, you just delete that one.
You want it? Oh, you're right. Maybe you're right. Maybe that is the reason. Oh, okay, yeah, you're right. I cannot delete it. Oh,
Now you can.
yeah, maybe that could be the reason. you're
Now
right.
you can.
Yeah, this is the reason.
Draw
correct.
another one. No.
No? Why? Just very weird. I don't know. Oh, maybe that one not working. That one not working.
Yeah.
That one not working.
Oh, just give.
What?
Even this one. Yeah.
No, you cannot do it. You can't do that.
Yeah, it's just.
You can't do that. You have to click this one. Let me just click that one. I don't know why they're not working. You see?
Yeah.
Oh,
Oh,
yeah.
yeah.
You have to click
Yeah.
this one. Yeah, that's good. You want that data?
Yeah. Let me.
No, you can do.
You
You
need
can.
to do again.
Yeah,
Yeah, I should do it again.
Oh, okay, good.
Yeah, something like this.
It's good.
Yeah, we need something like this. Yeah, I should measure. From
Oh,
here to here.
let me tell you. In that case, for example, if this white one is about 5, and this one is the lowest one, the black one, about 8, the difference between is about 12. You mean like that?
Yeah. Oh. Just let me take a picture of this.
What?
Yeah, this one.
No. Tell me that one, Milan.
What?
I don't know that.
What?
Here, this is the highest one, right?
Yeah, this is this one.
Okay. This is the lowest one, right?
Uh,
About 500 is about here.
Here, it's here.
Not
The
there.
darkest.
Not there. This is 500, more than 500.
Yeah, this is more than 500 and.
Yeah, most of is here, right? It's here.
Yeah, maybe it's here.
Oh, okay, I got it. I have idea. In that case, this one, let me see, less than 250, right? Is about here. Oh, that's correct.
Yeah.
Yeah, that's correct. Yes.
So the height difference, for example, from here, it's
Now,
8 and 4, 12, around 12, 13.
around 13.
13, yeah, between those two.
And also, you can check this one. It's more actually.
Yeah.
This is 4, this is 0. About 4, this one.
Yeah, and how about this one?
Oh,
This
about
one
8.
is-
Sorry, about 8. From here to here. About 8.
Yeah, that one is, yeah. So can we just increase some tick points here?
No, I don't think so. This is out of scale.
Huh?
That's out of scale.
What do you mean about this scale?
I mean, machine did the scaling.
No, I know, no, just here.
I cannot change, I told you. How do you change this one? Profile range?
What's that?
I don't know. No, I don't think.
Okay, no problem. Yeah, it's fine. I can extract data from
You can use other software.
Yeah, I can extract data. Yeah,
That is very easy, right? This is not difficult. You can use other software.
yeah, it's fine.
And also, the grain. Oh, sorry. What is this mouse?
I think maybe you should delete this.
Oh, yeah, could be. You mean this one, right?
It's not doing anything.
It's not working.
Oh, there, it's there.
Oh. And also, grain, this one you don't need, right? You need this one, I think, for roughness.
Okay, what's
That one is
what
very,
does show?
that one is very important. This one is called power. Power spectrum. Spectrum, scope, density. This one describes the roughness. You need to do research on this one.
Okay, I don't know. I have no idea.
No, you need to do.
Yeah, okay, I will.
Yeah.
Look it up. Okay.
I can just give you information, okay?
Okay.
Yeah. And also,
What's this rough?
this also is roughness, yes. This roughness from -12
Mm-hmm.
to about 7, right? Nanometer, this average, this range
Mm-hmm.
is called this one.
Okay.
The highest one is here, right?
Yeah.
Yes, and also there are a lot of data here. And also 3D, this one you can add here, this one.
The image size is different.
Oh, cannot.
These are the.
Oh,
large
okay,
images.
yeah, this is 10, this is 1, right? We cannot put them together. Can maybe try here? Oh, this one is good. Okay, hello?
So, can you save the 3D line, 3D image also?
No. All of these data are saved. You need to
Like this?
you need to copy this one.
Yeah, okay, I will. So, can we do another run without these lines?
And I don't know that. And I need to check, okay?
Okay.
But maybe we need to change this one. Right now is 0.81. 0.81 volt. Let me increase to 1. How about that? Oh. Let me increase to 1 volt, okay? And clean, and this one, let me put 0.8 here. We didn't do anything, right? We didn't leave that, right?
No.
We just do approach even we don't need it, right?
Mm-hmm.
Oh, I have to mention about that. When you do anything change, don't do it before you leave it out. That's very important. Otherwise, you may damage the probe or there's another thing is head. You may damage it. Okay? This is why the machine puts this one and this one together. You see, this is very important. Always mention you guys. Don't forget that.
Mm-hmm.
Right now, since we already did approaching, right? We don't need to do anything. And also, before you click scan, you have to uncheck 9 scan.
No?
Lines.
9 scan.
Okay, thanks.
Don't forget that. Okay? And then to scan. Let me try again, okay? I change this one.
What did we change?
I changed that. From 0.81 volt to 1.
Why we change that?
Because this is not so good. Maybe we want to remove the line. Did you remember we have that line?
Yeah.
Yeah. But that line is different from this, not that line. Maybe this is your sample information.
You mean those lines are?
No, that line is here. This is here.
Yeah.
Not this. This is your sample information.
Yeah. Okay.
Just, you cannot remove that from here. You know what I mean? That line means your picture maybe is not so. Let me show you here. You see that line?
Yeah.
I want to remove that line. Not,
Yeah, I know.
Not that line.
No, I know. Yeah.
Yeah. Scan, okay?
Yeah.
Or maybe if you don't want that, you can change that one. To 0. People would like to use this one, right?
Can we change while it's doing scanning?
What? Change what?
It was scanning and we changed the parameter.
Could be. Oh no. When you start scanning, don't change anything. Could be okay, but I'm not sure. Don't do that.
Because it was scanning and you changed the parameters.
No, I did uncheck. I stop it. I stop it. If you want it, I told you, if you want to change something, it's better stop scanning.
Mm.
You know what I mean?
Yeah.
Yeah, don't do that, okay? I don't know what happened to the machine, but it's better. Don't do that. Or become worse.
Yeah, it became worse.
Oh, that's not good. Become worse. That's not good. We need to go back, maybe decrease this one. That one, 0.8. Let me point 0.75. And this one still keeps 1. Oh, because that one is better. Oh, that is better.
Yeah, it's good.
Oh, that's good.
But it has
A little bit, right?
Yeah.
That is much better.
So what's this parameter?
What?
This one that we changed. What's that?
Oh, that one is Z gain. Z gain means in that direction.
Okay.
Maybe the probe obtain some change. You know what I mean? This is like that. Z gain means Z increase a little, right?
But we changed the set point.
Oh, you mean that set point? That one?
Because we are changing.
Oh, you mean this one?
Uh-huh.
That set point. Oh, that set point. I don't know that. It could be still related to the distance between tip and the surface. You know what I mean? Yeah, it could be because that one is always vibration like that, right?
Mhm.
And then if you change that one, you may change the distance between this one. Because there's a voltage, you know, between this one and that one. This is voltage we use, right? Or you can switch back to distance.
Mhm.
Did you remember before? Nanometer? Later after that, okay? I think that's good. It's not that bad. That is good. But still, you can do yourself. You can change this one, that one. If you want to get a very good picture, you can do yourself, okay? I don't want to make for you, okay? It takes time.
Okay.
And tools and others user will come to use machine. What time now? Okay, maybe easy now. And also, I think I have to give you guys to try yourself. I cannot do all the things myself.
Yeah.
You guys need to try. You go first? I'll be back, okay? Wait. Yeah, I think that's good. The picture is good. Anyway, you can change it, right?
Yeah, I should change the set point.
Third point, yes.
So did you decrease it? It got better?
Yeah.
The decrease is better, yes. Now you have to have idea of everything, right?
Yeah.
How about you? And also you need to try yourself as well. Yeah. And also, you said this color is not quite different from yesterday. You said yesterday is quite different?
Yeah, yesterday it was green, now it's silver.
You said it's not different, right?
This
Not
is-
quite different.
Now it was different.
Quite different?
Yeah.
Oh. So here, okay. For Z drive is care about the height information, okay? And also you have to have the error signal because that will show you if you got a problem or not. And also height. Height is the most important, right? You have to have this one. And NCM amplitude. Amplitude means from here. This morning I adjust this one for a long time to get it. But this one you have. This one I told you guys you need to do the sweep. Sweep scanning. Sweep scanning kind of you have to find this peak.
Okay, what's that?
That peak means your frequency. If this one, you know, this
Frequency of
frequency,
what?
yes, amplitude. This the figure is amplitude as a function of the frequency, right? They must be like that.
So the cantilever is going like this.
Yeah, yeah,
really
yeah.
small.
Like that.
tapping.
Yeah, right.
And-
No, this is not tapping.
Yeah,
It's a non
I said
contact.
like tapping.
Like a contact, like that, like that.
Yeah, it's just oscillating up and down.
Yeah, because AFM is detect the
Right.
force of between atoms, right? Yeah. This is why maybe there's an active attraction force or repulsive force, right? Yeah. This is why the tip can get the deflection, and also laser will detect the deflection, right? Yeah, this one is important. You have to get this. If this one is very bad, the data you get won't be useful. This one must be like that. This is kind of Gaussian distribution, Gaussian peak.
Okay.
Yeah, okay. I did this morning. I checked it and I got the data. I found the drive about this one. This I write down here. You see, and also resolution frequency. From here, you may find this one. And let me see. So what is this one is? So what is called this one called? Let me check what is called. Let's see. Oh, this one. So this one. This one you get those kind of data, and you see the frequency. Resolution frequency is about 330, right? I got the resolution frequency about 268. This is not big difference. This is good. And also this force constant is about 42 Newton per meter. Now this one you don't need to care about it, okay? That you don't need to care about. But I suggest if you cannot get very good result, you need to do that one. But to do this one, you have to select the non-contact mode, and also you cannot your tip cannot approach to your sample. If you approach it and do that one, you will damage the probe. That is very important. This is why I remember I put this note here. Approach, before you approach it, it's recommended to set the scan site to that doesn't matter, and serve again from here. I put number 1 here, but you can change this one, and also you can change this one as well. Depends on how clear your picture is. If you find it's not very blur, you have to change this one. Set point here, this servo and the gain. I found it that's very good, so I fix it there, okay? And also, don't perform frequency sweep. This is very important after approach. If you click the approach means it means like that. Okay, your tip goes down, approaches to your sample, right? After approach is down, it's very close to your sample. In that case, if you do sweep like that, right? You damage probe. That's very important. This is why I put this one here. Don't move the XY position. If you did the approach, don't move X and Y. This is why you can do XY. This is XY stage. You can adjust.
You mean this one? It's the same.
Almost the same as that. This is why yesterday sometimes I use this one. Do you remember? You can use this one as well. You see, this direction, this way. You have 8 ways to do, right? Don't do that, okay? If the probe already close to your surface of your sample, don't do any other things. Only one thing you can do, just scan, start your working. Otherwise, you damage probe or something else. Okay. And also, once you approach to your sample, don't turn off the beam. Beam is here. In that case, you cannot do that. You cannot turn it off. Don't click this one. You can use this one. You can click this low laser. You can add laser here, right? Once you click this one, don't do that. Okay, and also I have to tell you guys to know this one. For that was the lift, okay? Then also, for example, if you want to change sample, you can do like that. Because sometimes maybe you don't want any, right? You want to just change your other sample. You can do like that. Select this one, or just click this one. One click, you get 100 micrometer lift up. Okay. If you want to make sure it's easy to change your sample, you can change all of this data. If you do a lot, too much, maybe it's not good because maybe that one you will lose your laser again. Don't do too much. Okay? If you do too much, it's not good. This is why the machine is put 100 micrometer here. Okay?
Yeah.
But anyway, you have to make sure for you it's easy to take your sample out. Otherwise, the probe is very easy to break. Okay? And I think everything now is done. Maybe see. Other thing maybe I have to tell you guys about the other. Okay, so this one, lens. And also this is scan rate. Scan rate also is very important. This one, if you use very high scan rate, you may get a lot of this straight line across your picture. You know?
Yeah.
And also you may damage it. But if you get very slow, maybe you cannot. You move very quick, you may get a lot of noise. Okay, kind of noise. And if you're very small, use it very small, maybe you cannot. That one will be scanned very, very slowly. It's hard to track the information, the surface. In that case, also maybe you cannot get very good picture. This means the scan rate is not that high, is not that lower as well. You should find the very good value for your scanning. You can adjust it, but don't adjust a lot. Okay, and also that one. And also this one I didn't tell you.
Yeah.
This one is pixel. Pixel means this stuff. Everybody knows it, right? Doesn't matter. But definitely, if you increase it later, data in picture becomes very clear, a very good picture, right?
Yeah.
But most times that engineer said, don't adjust a lot. Just keep it 256.
Okay.
Yeah, 250. This one, you can adjust, but from here. But you don't need. Maybe you don't need that high, right?
Yeah.
You cannot get it this high. That high maybe is not necessary, right? And the size, scan size. This means.
So it's always going to do a square, right?
Always a square. Yes, always a square. You can scan very small area or big area. So
Yeah.
the biggest one is 50 by 50. It's not that big, right?
50 by 50 micrometers?
Yeah. This is why
Okay.
yesterday I told him, if you want to do the measurement of the thickness of your thin film,
Right.
maybe that one is not so good.
So for this sample, could we do 1 by 1?
Yeah, in that case, but it's too narrow. or too small. Maybe you cannot get more information, right?
I think from this we will.
Maybe profilometer is better in that case, I think.
Huh?
In that case, okay, let me see. Like that. Okay, this is your substrate. This is your thickness, right? Oh, sorry. Yeah, sorry. Thin film.
Yeah.
Okay, if you because this one use very very small area,
Yeah.
kind of this. Okay. You can scan very very small area, right?
Yeah.
But profilometer you can scan very long.
Right.
Range.
Yeah. Well, you're talking about thickness. Yeah.
You know what I mean?
Yeah.
Yeah. If you just want to get that, maybe I think.
No,
maybe
this is completely different.
Yeah, completely different. You're right. Yes.
But for this, I would want a 1 by 1.
You want one by one, right? Oh, okay.
Because I want to see.
For you, maybe it's different because you are single crystal, right?
Yeah.
You are saying
what I want to see is the surface roughness of
Right.
my foam.
Yeah.
And so I need a 1 by 1, and the roughness is going to be from these ridges.
Okay.
So I want to be able to measure how thick is this little
Oh,
ridge
okay,
right
okay.
there.
But in that case,
what
you
the
can
depth is.
use one by one.
Yeah.
You can use one by one. You want to use one by one, right?
Yeah.
Okay. And for this one, maybe
Yeah, I can see how much smaller that area would be.
you can
Yeah,
zoom
and see
in,
this,
zoom out.
and now it's easy to measure like how thick this is.
Oh, okay.
And then also measure the height difference between here, the bright,
Yes.
and here in the dark.
Oh, okay.
I want to measure the height because the bright is higher.
See, in that case, AFM is very useful.
It's
for
the
you.
best, yeah.
It's useful than profilometer.
Yeah.
yeah. Well,
Yeah,
in that
profilometer
case-
is useless.
But if you want just want the
Right, of
measure
a normal film, yeah. it's
yeah.
not good.
In that case, it's not useful for you.
Yeah. Profilometer is better.
Yeah. Profilometer you can measure very long range, right?
Yeah, exactly.
Yeah, that you cannot. It's very small, right? Just
Yeah.
1 by 1 or 50 by 50. 50 by 50 micrometer is very
Still small, yeah.
very small, yes. Okay. And also this one that one is rotation. Rotation means
okay.
you can do scan. It always scan like that.
Right, but it can go like this way.
Yeah, you can. No, it's said like that. Go this way, this way, this way. This from 0 start. If from 100, maybe go up,
Okay, yeah.
go
Yeah.
down,
Yeah.
up to down. This is
Yeah.
down to up.
Right.
Yeah, this is different.
Doesn't really matter. I
That doesn't
guess.
really matter. This is,
Yeah.
you for example, if you choose 0, that is okay. Yeah.
Right.
You see?
It'll just start from
yeah,
there.
start from there, yes.
Yeah.
Okay? And this is this one. And also, let me see here. That one, this servo I already did it, right? This
Yeah.
servo, this one is important. That one is important.
Yeah.
You can decide the quality of your image.
Yeah. Okay.
You can change this one. If you find it's not good, you can change this one and maybe click normalize, and then you will get the voltage.
Mhm.
Change that one.
Mhm.
If you find it's very blur, you can adjust this one.
Yeah.
Okay. And also this bias. Bias is we cannot use it for the normal.
Right. That's
use.
for that conductive.
This conductive, you're right.
AFM.
Just for conductive AFM. Don't do that.
Yeah.
Don't do that, yeah. Because for conductive mode, you need to change a lot of the.
The setup.
The setup you have to change, yes. A lot of things.
That for some of your samples, Milad, that's what we really want to do.
Okay, yeah. And also this is done, right? That one advanced. Maybe I think I don't think we need this one as well.
Yeah, I
Maybe
think that's.
Yeah, most time we don't need that.
Yeah.
This one is always like that. This doesn't matter. We don't need that as well. And also this one here, that was the scan position. That was scan data you will get.
Mhm.
This one, okay. And, but most time we just put like that, okay. And also, once this one I already told you guys, right? This one, I have to tell, maybe you don't know that. This channel, once you click channel, you have to click the edit.
Mhm.
Click this one and then this one, you will get this. And then from there's a lot of the parameters you can choose.
To look
Choose-
at on the side.
Yeah. Choose what you want.
Right.
For example, let me call anything, check anything, okay? Let me check this one and add it,
Yeah.
like that, okay? But for you, maybe you don't need this, I remember.
I think actually, yeah, or X scale or X scan,
Yeah.
because that'll let me measure the.
You
width.
need this one?
Yeah, to measure width.
How about Y? Maybe I can choose.
It depends on the orientation of the image,
Oh,
whether
okay.
we want X or Y.
Okay.
So maybe just put all.
Put all?
Yeah, X
Okay.
and Y.
You want it, right?
Yeah.
Okay. So
Because
what-
that way I can measure like the width
Oh,
of like
okay.
the bright.
Oh, okay.
What's the offset?
I'm pretty sure offset. You pick 2 points, and it'll just tell you the offset between those 2 points.
Okay.
Or you can just do scale and draw like a line. There's like different. They all measure basically the same thing.
Oh, too many charts.
Okay.
It's too much. I think
Um,
we take off. How about this?
Maybe take away
What?
area signal and
You
it's
don't know what it
phase.
is?
Now it's
Okay.
six.
Oh, maybe it's good. Okay. Next. This one. Total 6, right?
Mhm.
Total 6. Okay. And also come to this side. This one side here. See you have to first you need a let me see, sorry. This one.
I guess set the file.
Set on your file. This is, you have to get this one. This morning I pulled the let me see. Let me see here. I set up the folder for you. This I did it this morning. This one. I remember where. Oh, this one. This is already there, right?
Mhm.
I set up the this one, SPM data. From here, from this folder, you can set up your own folder here. I set this one here. Okay, click this one, select this folder, then you come here.
Cool.
And the file will be automatically saved. You don't care about that.
Mhm.
But you need to care about this one.
Yeah, the name.
What name? File name? Clear.
L-0.
Yeah. This is you need for this one. Okay. And this one done. And this one you don't need to care about. This is also I don't think you need to care about. This one, what does it mean? This means if you done, if you select this one,
It'll lift the probe.
yeah, after done, machine automatically lift off the probe.
Yeah.
But most time I told you guys just click this one after you done. This one I didn't select this one. Okay? And others, this is scan area, yeah, automatic scan. So you have to use this one.
Mhm.
The scale.
Makes
Machine,
sense.
yeah, you have to use this one. Okay. Or if you want to repeat the 2 times or 3 times.
Will that increase the resolution or?
No, that doesn't help.
Oh, okay.
Yeah, don't this one I didn't
Yeah.
select.
Okay.
Even you can select 100 times, it's not necessary, right?
Yeah.
Yeah. And also, this controls here, this line scan, you see,
Right.
that one doesn't, not that scan, that scan is real scan. You get
Yeah,
picture.
like a.
Yeah, but this one is not. This one you
So
don't.
that's just a single line.
It's a single line, you cannot
Okay.
get anything.
Well, you
And-
get some.
And also the NCM sweep is this one, I already did it.
Mhm.
If you found it very bad,
Right.
you can do that.
Yeah.
But I wouldn't like suggest you can do that. This is hard to adjust. Yeah. If something's wrong, you need to do that.
Yeah.
Yeah. Yeah.
So
And
it's-
also-
it's still doing the
I
line
will-
scan, right?
Yeah.
How do you know when it's done?
This one.
like right now it's still
if
going,
it's
right?
always like that, it's always scan like that.
Yeah.
But
Yeah, it's still-
unless it's unchecking.
Okay.
Yeah, that doesn't matter. And also here, this one, what is this one? Let me see. rearrange the position of the trace. This is not, doesn't matter. This is about this one,
Yeah.
about those. And this one is a pair. This means a pair. This vertical
yeah.
lines. You see?
Yeah, that's where we can get
Yeah,
like the
you,
XY
you,
data.
yeah, you're right. Yeah, you can grab it. You see?
Yeah,
Yeah.
that's good.
You can drag it, not grab it.
Yeah.
Drag it, right?
Yeah.
You can drag it, and put the curves is here, or you uncheck the curves, then nothing. You see?
Cool. Okay.
Yeah. So, most time,
Yeah, I
so
would
people
use it. It's
people use
nice.
this. People use this one. Yeah. And also that one, I did it. I did one 3 on page,
Yeah.
4 or more. You can do it like that.
Right. The other one.
But we just select 6.
Yeah.
The machine doesn't allow, right? Didn't allow.
Yeah.
Yeah.
Okay.
Yeah, it's good. And also this one maybe most time we don't use. If we do like, for example, if you want to go Young's modulars,
Mhm.
mechanical properties,
Oh, that's cool.
maybe you need to use it. You have to use this one. In that case, you use this one. But most time we don't use,
Yeah.
right? In that case, you have to use the contact mode,
Mhm.
not non-contact. Okay, this one, I don't think today we need to use this one. And this one is for, this IV curve.
Mhm.
This
Yeah.
one for IV curve.
That's cool.
Yeah. And also for IV curve, I think maybe that one. Let me see, I remember that one. You can choose from here.
Yeah.
You see the IV curve.
Yeah.
Do you see the IV curve? Okay? I don't notice. Oh dear. And this, I already told you, right? This one is the same as this one. Left is this stage. Right is focus.
Mhm.
This is the same. That one is I already told you guys, right? And also this one I already told you. I think everything is fair. And also you can do auto scanning. Just let the machine do it. But this is not good.
Mhm.
It's better you do yourself.
Mhm.
Manual is better. Okay. And programs, I think this nothing. I think this is almost the same. Okay. This is, don't care about that. And also browse is the same.
Load files.
Yeah. That's why you don't do that because this if something wrong, I need to do that. This is mentalist.
Mhm.
Yeah, you guys don't do that. And also, let me see. And also this one position, you can do that kind of easy to find where you want to do. No, maybe kind of like a automatic find.
Yeah.
Yeah, find position.
I think when you go somewhere, you click that and it'll mark that
Yeah,
position,
yeah. I see. This one
and then you can come back to it.
come back to where?
Like I think if
What do you
I remember like when you find a position you like,
yeah.
you can like mark that position, and then if you move away
Mhm.
from it, you
Mhm.
click it and it'll automatically move back
Oh, really?
to the same position. I think.
Oh, I don't know that. I don't know.
I think.
Okay. And that image you don't need to click.
Yeah.
You will directly or automatically get there or get the image. Okay. I think that one. Oh, and also this one, you can expand this one. For example, if you want to adjust this one, you need to go there, right, to adjust, to do alignment. You
Yeah.
have to use the big picture, right? Yeah, in that case, it's for you.
Okay, yeah, that's nice.
Or if you don't want it, you close this one, or you do the shift. Oh, why is it not working? Oh, it should work. I remember it should work. I don't know why not.
Opens it, just doesn't close it.
Yeah. Okay. That's good. That's all.
Mm-hmm.
Now, what we need to do,
Approach and scan.
remember this C drive, or you add these two, right?
Yeah.
I think we need to check this one. first, okay? Otherwise, we didn't get that. X, Y offset, right? Y, oh, yes.
Maybe I'm not 100% sure if we need it, but.
X offset. But anyway, it doesn't matter. You can add it, okay? Yeah, just come here.
Cool.
Yeah. Well, honestly, yours is mine now. It's here, right?
Yeah.
And then after, because we already adjust this one, right? In that case, we just need click approach it. Yeah. Right?
It's doing.
No, machine should show. Why there's no window? Come on. It should come out. It's down, but it should. Oh, we lift it up or not? We didn't lift it, right?
What?
Did we lift it up?
Lift it up? No.
We didn't do it, right? Well, then we need to focus on that first. This sample, right? This sample, right?
Yeah, that should be something.
Uh,
If you do scan, then I think.
No. Yeah, I found it. Hmm?
Yeah,
That is
that's my
all.
sample.
Yeah, that is very good.
See, even the line scan is useful for my sample.
Oh,
Because
really?
just for the height, you can see the difference in the peaks
Oh,
and the
okay.
height here. But as far as width, it may be inaccurate
Yeah.
because it's measuring it diagonally,
Yeah,
and we need to get like a point here and here.
okay.
But if it's going like this, it'll measure it wider than it truly is.
Okay. Oh, this one. Then to approach it again. Oh, yes, that must be get this one. Otherwise, because maybe it's not also. Now it's done. After everything is done,
Yeah.
only click this one. Scan.
And then that'll do the 2D scan.
No, that one.
Not line
The
scan,
whole
right?
range,
You're gonna
yeah.
do the whole range.
Right, the whole, yeah, right.
We need to close this or?
It's better if you want to get very accurate data.
Yeah, so no vibration.
Yeah, there is no vibration, yes. Sometimes you just air to come in and out and they're not good. Yes, that's true. Yeah. If you found the picture, the image very bad, you have to adjust this one, okay?
Right.
This one
The,
and also
the gain thing is.
and also scan rate.
Yeah. Slow
This
it
is
down.
very important.
Okay. It looks like it's pretty good quality.
Pretty good.
Looks pretty good.
Let's careful, I think this is 9.
Oh, those lines, yeah.
This line is this one. I
Maybe too
remember.
fast.
Yeah, maybe I remember right something for college.
Maybe it's showing.
I remember somewhere I found it. He will get the deflection. Laser is to track that deflection. This is why we have to use the laser. Okay, so this is the first one. The second one is you asked me the cantilever, that one to show. Now that one is we have two kinds. One is 15, one is 14, or 15, one is 5, right? You ask that one. Here I found that this one is like that. Notice cantilever shape is like that. Okay? You said this one is about 3.4, and then we call this about 4 micrometer. This one, that one is about 5, like that. The other one is maybe 15. But this one, both, there's not big difference because you can use this channel to select that one. for this, this was set up, right? We use this one to select the non-contact mode here, and from here we select the cantilever based on the number on this one, and the letter on this one. You have to use this one to choose. Okay, select. There's not big difference between them. Okay, both are non-contact mode. Okay, the other one, and also usually to do AFM prior to doing the AFM, we have to do the this one. To maybe right now I didn't turn it on. Okay, so click the NCM suite. For suite, this one we why would we do that one? Because we have to find the shape. This shape must be like this one, kind of Gaussian distribution. You know what I mean? Yeah.
Which one?
No, because this always yesterday and also you asked this phase, right?
Yeah.
Yeah, because like this kind of thing, this degree, you see?
Okay.
Yeah, this phase, right? Degree of phase, right? And then you find these two, if you do X, Y, NCM, the sweep, you will get this kind of the Gaussian distribution. In that case, you will get good data. This is why some, usually, as required, you should do that. But after adjusting, you get very good shape, you don't need to do that. Okay? This is this one. And also, the others, and also, you asked about the difference between SEM and kind of these kind of things, right? AFM is different. The key important difference is AFM can get the 3D scan. This 3D you see kind of this one like. Yes. Right? This is the green side, not green side. This is your, if you sample the polycrystal, you will find this green side, 3D green side. Okay. But this is your single crystal, right?
Yeah,
this single, maybe there's something.
I have
it's a little high. This a little bit. It's uniform, but not that uniform. Mm-hmm. From this picture. You find it here, this is very tall, this is why. Like maybe something like that. And also from the 2D you will find there's something.
Yeah, there are something like this.
Right. Okay. And let me see. The others, I think maybe they're okay. And also, as I told you guys yesterday, that one is very important. But still, I have to give you guys a little bit knowledge about it, how to do that. Okay, come here. This very maybe if I am not here, if you want to do AFM yourself, I think it's better for me to let you guys how to operate. That would be better. You know what I mean? Otherwise, if I'm not here, you cannot do it, right? Yeah, because after I put I can give you the right to access to AF. You can do yourself. Yourself. I shouldn't be here, right? This is why I said that it's better to ask you guys to do that. Those two, to adjust adjust that one. The tip, this one, up and down. This one we call Y, this is X. And this one right and left.
The camera, you mean, or?
Kind of the camera, yes, kind of camera. Yeah, camera takes picture of takes an image of your probe, right? Yeah, and then you can move this one. Yesterday I did it. Let me try again, okay? Yeah, you see? Mm-hmm. And so, this one? Because I don't want to Otherwise, if I move a lot, we cannot get that light in. Okay. Okay, this is another one, another pair. This is 3 pairs, okay? So another pair, this is called the laser alignment. Laser alignment, this one for X, this one for Y. For the Y, when you turn on the laser, you will see that one. Do you see the laser? You have to turn on that one first, and then go here to click this one. Okay? So this is very important. And the laser, if you have to find very, very strong laser, you got to see, I just a lot. Well, I just very slowly to find this strong laser. The laser body is here. You see this very bright one? Yeah, because I just move a little bit. This one looks like this is not there. Oh, sorry, not this one. Sorry, this one. Like that. This one usually should be around half of the length of probe.
In the middle.
In the middle. If this one about the length, this strong spot should be around here. A half. In the middle, okay? In the middle. And those two really do alignment. Why this is for X and for Z axis, up and down. This one also we call Y. Okay, from here we call Y. Okay, from here we can up and down, kind of Z, right? But actually this one we call Y. This called X. Okay, from left to right, right to left. This is called X. Okay, do alignment of the laser beam. This beam. Okay, you have to find the very strong spot. Like this one, you see, so there's a beam. And also those two, we call it PSPD, adjustment, alignment, okay? PSPD, P is, I told you yesterday, P is position, PSS is sensor, and PD photo detector, PSPD. Use this one to alignment for that. For this one, you adjust. You can move this. At the beginning is red spot, right? Yeah, you can adjust this one to the center, the origin. In that case, you will get higher. This one must be maximum. Must be more than 2, but less than 3 or around 3 volt. This is very important. Otherwise, you can't do anything. This is why yesterday we can't, because we didn't find it.
Yeah.
We-
What was the
yeah.
problem yesterday? We couldn't do it.
This is probably because we move out of range. This is why. We cannot find that one. I told you it takes time. Because at that time I have other things to do. I cannot work with you guys. This is why I don't have time at that time. This morning I come here to just get it, put it back. But like this one, like the manual, I put it like here. You see, first you need to find this white spot, this strong laser, and move like that. If you didn't find it, if you don't, you cannot find it, you cannot get your laser. This is very important. It's out of range, and you can, it takes time to get it back. This is why usually I told the user, don't adjust a lot. Now sometimes it takes time to get it back. maybe yesterday, because he said maybe this not his sample, I did a lot of adjustment. This is why moving out of range. This is why. Okay. And also, maybe I suggest you guys to read this up. If you can't do yourself, it's better to read. I haven't completed it yet. I have to add others to the figure. I will add others not much more important. This is why I haven't put it here. Okay? Yeah. And also, I told you guys, the probe, the tip, very, very expensive. You know, one piece, $30 per piece, right? It's very expensive. Yeah, if you break it, I will lose $30. I charge the user is $25 per hour. If you break it, I didn't get anything, right? Yeah, this is why every time I told the user, don't break the tip. If you want do it, please follow this instruction very, very carefully. Or if you break it, maybe next time I don't want to give the tip to you. You need or you need to pay, and then I can give next time. Yeah, the tip we don't have enough. Also, it is very expensive. We bought this machine. We bought $1,000 for the probe.
How much did you pay for this?
What?
How much did you pay for the whole laser?
It was almost 140K. Expensive, right? Yeah, a lot. Okay. And now let's start, okay? For this one. And also yesterday, I told you guys this is head. You need to do the beam. Okay, this one you know how to adjust. And also this one move the kind of the head to the where you want to scan on your sample, right? This one also very important. For this one, you can use this stage. For example, this stage, this stage, move up and down, close your down to your sample or lift away from your sample. You see. Let me see. Oh. Do you see? Maybe too much. And then let me focus.
Why it's not green? Yesterday the sample was green.
Yeah, you're right. You see this laser is here, right? You can see the laser spot, right? Almost here is okay. Last time that the engineer said is better. This way is better. Sometimes you can put it in the center, but here is good. He said. Okay. And also, if you want, if in that case, if you want to find where you want to scan, you can do like that. To move this one, Why cannot move?
Oh, it's moving.
It's moving?
Yeah, it's moving.
Oh, it's moving. Okay. And or what you can do, you can double click this one. It should move.
You have to double click the arrow.
No, anywhere.
Yeah.
Double click anywhere. Oh yeah. You see? The move out of your sample, right? This is out of your sample. So I need to put it back. It's here, okay? Or if you want to do like that, double click, right? Just double click. Yeah.
So is there an easy way to find like the very center of the sample?
Yeah, you easy to find. But right now maybe it's hard because right now I focused on the tip.
Yeah.
You write down your sample.
Yeah.
This is why we have to clear a little. This stage must be a little bit close
Yeah,
to
closer
some-
so the
Very,
sample is
very.
somewhat in focus.
Yes.
Almost on the sample.
Almost down.
Yeah, it's almost touching the sample.
Do you see? This is your sample.
Okay.
This is your sample.
Alright.
That is your sample. This is edge. You see?
Yeah.
Yeah.
It's kind of good at the center.
You want to go to center?
Yeah. 'Cause the film quality is different depending where you are. But in the center, it's the best.
Oh, well, what is this one? I don't know.
I
Maybe
think
this
it's
something.
you're close to the edge again.
What?
I think you're close to the edge again.
Yeah.
Close the edge?
Yeah.
Yeah.
Oh.
Like go up and that way.
Okay. How about this?
Yeah. More.
This way?
A little bit more. Yeah. Like
More?
okay. Yeah. There is.
Well, I thought you have a lot
Yeah,
of
it's a center.
You have a
It's
lot
good.
of this one. What
Yeah.
is this one?
I don't know.
I think you
Those
guys,
are different sizes.
no, I think you guys you should focus on that because this is
Okay, but
yeah.
but right now that's not what I care about.
You not care about?
No, what I care about is this. And
Right.
so I would want to
T-shirt?
take like a smaller area.
Yeah.
And then I can measure what the height difference is between these ridges.
Oh, okay.
You know what I mean?
Oh, okay, yeah.
And the width of the ridges.
Okay, then we can go here. How about that?
Yeah.
This here is okay,
Yeah.
and then you can do let me do focus, and then focus. Right now, because
So
we've
that's it.
already found
Yeah.
the location.
Yeah, so now we
Now
focus on the tip.
Focus on the tip. Yeah.
Yeah.
Yes, you're right. Maybe that's okay. Doesn't matter.
Yeah.
Yeah.
Okay.
Sometimes the people do like that. Focus on the sample. Oh, that's still. That is the same, I think. Yeah. We can do like that, okay? How about that?
Yeah.
It's okay, this laser is here, right?
Yeah.
And then in that case, after everything done, maybe I will tell you that one. Yesterday I told them, okay?
Mhm.
This one, click this one, you need to
With all
find
the different strands.
different mode, okay? This contact mode,
Right.
taping mode, and non-contact mode,
Yeah.
there's a lot, right?
Yeah.
And it's also, last time you mentioned about the
Conductive AFM.
yeah, AFM, right?
Yeah.
This conductive. I
Yeah.
think from this one you can get the IC code.
Yeah.
Yeah. Okay, we have even this the thermal AFM like.
Yeah.
We have a lot.
They have
We have 7.
they should have KPFM somewhere. Maybe it's just
Capacitance,
No, a Kelvin probe.
Kelvin probe.
Yeah, it measures the potential energy.
Yeah.
surface.
Scanning Kelvin probe microscope.
Yeah.
Is
I
this
know-
one, right?
Yes. KPM. Something.
What is called?
This one. The scanning Kelvin probe microscope.
Let me check with you. SK.
Let's see it.
This one should be SK, right?
Maybe it doesn't matter.
It may just be PFM. I don't know.
Oh yeah, maybe PM is probe force, right? Microscope, right?
Maybe yeah.
Yeah.
But we'll just do contact.
Okay. Once you select this one, you need to click setup. For setup, you need to click this one.
Mhm.
You will find a lot of this one in selections.
Oh, okay, yeah.
And then with this one, you need to use this one. You need to find that case.
Yeah.
From the case, you got your probe.
Yeah.
And then you need to put this one.
Okay.
The letters, NCHR.
Right.
Sometimes maybe it's not.
Yeah, so
It's
you
just for
need
the same mode, maybe it has different.
Yeah. So you need to check.
You need to check this one. That's very important. If you got the probe from here, you need to put this one here. Okay, maybe for the same mode is maybe there's a difference. Then there's more numbers. Okay, that one is good. After you select it, you need to click select, right? And also close this one. And also, after this one done, what you need to do, you have to do channel. With the channel, you need to click edit to select what parameters you want to get.
Okay, yeah.
That's very important. With this one, because you guys care about the height, right?
Mm-hmm.
That's why you from the height you will get information
Mm-hmm.
about the height.
Yeah,
The height.
the roughness.
And also it's a about roughness, yes. And also Z drive. This morning I found Z drive also is better to select.
What's that?
Z drive is almost the same as Z height. Okay. And also NCM, I checked it, I found this is separate information. Maybe I will show you guys.